Here we're going to look at two examples of factoring quadratics using the guess and check method. The first thing before we get started is when we factor quadratics, we are going to factor quadratics that are in standard form, which is y equals ax squared plus bx plus c. So we should see an x squared term and an x term. So if I look at my first example here, I do have an x squared term and then I also have an x term. So when looking to factor one of these with the guess and check method, we're essentially just undoing FOIL. Okay, so if you remember FOIL from multiplying binomials, we're really just undoing FOIL. Now, just to recap on what factoring is really doing, factoring is kind of like separating multiplication. Okay, so for instance, if I took 20 and wanted to know how I can factor 20, well, I can break 20 into 4 times 5. That would be factoring. Notice that I've separated 20 into 4 times 5, two things that multiply back to give me 20. So factoring is really just breaking things apart into multiples of itself. So for instance, if I looked at x squared minus 4x minus 45, and I wanted to factor this using the guess and check method, I know that I'm going to break it apart into things that multiply back to give me the original thing. And then I'm undoing FOIL. So if you remember FOIL, the F stands for first times first. So I want to think about what times what will give me the first term. Well, x times x will give me an x squared if I multiply it together. So my first two terms in each will be an x. I then want to think about what the L in FOIL stands for. It's last. So what times what is going to multiply? So I'm looking for things that multiply to negative 45 and will add to negative 4. Well, first always start with what multiplies to negative 45. And if you have to, you can jot things over here down to the side. So negative 45, well, I know 9 times 5, 15 times 3, and then I just need one of these to be negative in order to get negative 45. So these are both factor pairs. Now the next step is, once I have some factors of it, I need ones that add to negative 4. Well, if I look at 3 times 15, those are not 4 apart, so that's not the pair I want. But if I look at 5 times 9, I notice that those are 4 apart. I want them to add to a negative 4, so the 9 must be the one that's negative. So I can write this as negative 9 times a positive 5. Okay, this would be the factored form of the first example. Okay, remember that you can always check your work, and the way we can check our work is that we just undid FOIL. So if I were to FOIL my answer, I should get back to the original. So for instance, if I follow the FOIL method, if I take first times first, well, first times first is really x squared. If I take the outers, so if I take x times negative 9, well, that's negative 9x. If I take the inner, 5 times x, well, that's a positive 5x. And then if I take last 5 times negative 9, I will get negative 45. And then notice that these two middle terms can be combined. So I'll get x squared minus 4x minus 45. And as you can see, this is what I originally started with. So my answer checks out. So the factored form of this equation is x plus 5 times x minus 9.